following is an explanation of example 5.2 off of page 194. In this example, we have sulfur dioxide, SO2, which is a gas that plays a role in acid rain. We're asked to consider a 1.5 liter sample of this gaseous SO2 at a pressure of 5.6 times 10 to the third Pascal. If the pressure is changed to 1.5 times 10 to the fourth Pascal at a constant temperature, what is the new value of the gas? For this question, we want to use Boyle's law. This example is located in the Boyle's law section, which is a pretty good indication that we want to use Boyle's law. Boyle's law is quite simply a variation of the ideal gas law, in which we have P times V equaling a constant. This only works if we have constant temperature and a constant number of moles. If we don't have a constant number of moles, the question would be worded slightly different. It would tell us that we're adding gas or we're removing gas. Since it doesn't say that, we can assume constant moles. And the question specifically tells us that we have a constant temperature. Now, Boyle's law tells us that pressure times volume initially, so at time 1, is equal to K. He also says that at time 2, pressure times volume 2 is going to equal that same K. If this equals K and that equals K, then a simple algebraic substitution will tell us that P1 V1 equals P2 V2. Let's look at our values. Our P1 is 5.6 times 10 cubed, or 10 cubed, and our V1 is 1.5 liters. Now, normally we would convert pascals into atmospheres. However, we're given two numbers in pascals, so we can leave it in pascals because the conversion will take care of itself. 5.6 times 10 cubed Pascal times our volume of 1.53 liters equals, now for our second time, we have a pressure equal to 1.5 times 10 to the fourth Pascal times 10 to the fourth Pascal. And we don't know the volume. Is perform a little bit of algebra to move our pascals over to the left and get volume all by itself. To do that, we divide both sides by 1.5 times 10 to the fourth Pascal divided by 1.5 times 10 to the fourth Pascal. As I hinted at earlier, our pascals will cancel. The only unit left is liters. And we plug this in a calculator and we get an answer of 0.57. 0.57 liters is our volume. So our volume shrank from 1.53 to 0.57, because if we took the time to notice, our pressure increased from 0.56 or 5.6 times 10 to the third, which is 5,600, to 1.5 times 10 to the fourth, which is 15,000. So we went from 5 to 15,000, which is about an increase of threefold. So our volume should decrease by 3 times. And if we take 1.5 divided by 3, we get 0.5, which is fairly close. So it's a good idea, as always, to check our answer. Now, this can be done for any time where we have a constant temperature and a constant number of moles. Even though we've learned the ideal gas law, Boyle's law is simply a simpler version of the ideal gas law in which some things remain constant.